Hey there, physical science students. This is Mr. Ulark. We're in Vodcast 1.2, and we're going to take a look at metric conversions and the difference between vector and scalar. All right, metric conversions. You should be familiar with these, but we're going to cover them anyways. There once was the English system. It was used all through the land of England. And then, we came from England, or not we, but the United States was settled by the English and was an English colonies. So, of course, we brought English measurements with us over to America. It's a historical unit of measurement, and it was used in England through 1824. Now, in 1824, they redefined some of the units, got rid of some, and kept some. They made them more standard so that they were more widely accepted, and we still use a lot of them today: the inch, the foot, the yard, the mile, the acre, the teaspoon, tablespoon, cup, pint, etc., etc. We could keep going. However, they also came up with a system called the metric system, and this is actually more internationally accepted. It's used throughout the world, and it's more widely used. It's used in all countries except for, well, in the U.S. we do use it some. Liberia does not use it. Burma does not use it. The U.K. uses it, but they also use the English system still. Okay, the metric system is nice because it's based on a power of 10, and it uses prefixes to designate the power of 10 for the base units. Now, before we get into these prefixes, the base units that you need to make sure you know are the distance, or for distance is meter, and the unit is m, or the abbreviation is m. For mass, it's gram, and the abbreviation is a lowercase g. For time, it is seconds, and the abbreviation is an s. It's not SEC. SEC stands for Southeastern Conference. That's football, college football. This is time, S. And then volume, excuse me, volume is in liters, and that's a capital L. And the reason we use a capital L is because a lowercase l looks a lot like the number 1. All right, metric prefixes. So here are the metric prefixes, and there's a little saying that you can use to remember those metric prefixes. The one I like to use is, King Henry died by drinking chocolate milk. So the K stands, or King stands for kilo. The H for Henry stands for hecta. King Henry died, so that would be a big D, and it stands for deca. And then by would be your base units. Now, when you have your base units there's going to be just a single letter. Okay, it'll be meters, grams, seconds, liters, and there's other base units that you could have there. But if it's just a single letter, it falls underneath the base units. And then you have deci, lowercase d, centi is a lowercase c, and milli is a lowercase m. So, for example, if we had meters as our base unit, we would have kilometers, hectometers, decameters, decimeters, centimeters, and millimeters. Now, here, 2 lowercase m's, make sure if it's 2 lowercase m's, it's under millimeter. If it's 1 lowercase m, it's just a meter, and it's by itself, so it's a base unit. All right, so here's some examples for us to try real quick. Then after we try these, I'm going to do the first one with you, and then I want you to pause it. I want you to try the last 3, because this is what we're working on in class tomorrow. All right, so the first one, we have 15 meters. We're starting at a lowercase m, just one. And remember, lowercase m by itself starts here under base units. We're looking for km. So we're looking for the K, and we remember that K stands for king, which is kilo. So we're going to start over here. Nope, sorry, we're going to finish over here. Okay, that's where we're going to finish. Whoops, that's supposed to be an F. Sorry. And we're going to start here at the meters. All right, easy way to do this is you're just going to take and you're going to move over 1, 2, 3 times. Okay, don't count the letters that you moved to and from, count how many humps you have here. 1, 2, 3. Okay, there's this really silly song that we used to sing when we were kids, Sally the Camel. Okay, so if you know what I'm talking about, Sally the camel has 1 hump. Sally the camel. Okay, so think about that. How many humps does Sally have? She has 3. Okay, well, what direction did we move in? We moved to the left. So we're going to move our decimal 3 times, and we're going to move it to the left. All right, so look at the number, 15. Now, looking at that number, is there a decimal? Well, some of you will say yes, and some of you will say no. If you said no, it's because it's not really there. And if you said yes, it's because there is a decimal, it's just not written. All right, so if you said no, you need to know that the decimal is going to act as a period in this case. And if there's not a decimal physically present in the number, then we always assume that it's here at the end because the decimal goes at the end of the number, just like a period goes at the end of a sentence. All right, so we need to move that decimal 1, 2, 3 times to the left, so we're going to move it over 1, 2, 3 times to the left. It's here now. Physically move it, and we have to fill in with zeros. So our answer is 0.015. Now, some of you may ask, do I have to put the 0 before the decimal? No. This one right here, you don't have to put that there. I always put the 0 in front of my decimal so I can find my decimal. But if you can keep track of it and not lose your decimal, then you can leave it off. Okay, so now what I want you to do is I want you to pause this. I want you to try those next 3 by yourself, and then I want you to come back and check your answers. All right. Let's check this work. So let me erase all this so that it's not all over the place. And let me get my pen back. Okay. We're starting at 1.6 kilometers. So we're going to start with the K. And we're going to meters. Remember, meters. So am I going all the way over here to millimeters? No. I'm just going to the M by itself. If the letter is by itself, B, base units, by itself. They all start with B. Okay, so we're going to finish here as well. All right, so we got to count. We go over 1, 2, 3 times. Okay, so we're going to move our decimal 3 times to the right. So we come here, 1, 2, and 3, and we have to fill in with some zeros. Okay, we always fill in those spaces with zeros, and so we end up with 1600. All right, on the next one, we're starting with hectometers, and we're going to decimeters. So we're starting at the H, and we're going to the little d. Okay, so we're going to move over 1, 2, 3 times. Look, 3 more again. And we went in which direction? Well, we went to the right. So we're going to move this over 1, 2, 3 times, and we end up with 14.2 decimeters. All right, on the last one, we're starting at decameters. So on this one, we're starting here at decameters, and we're going to little m, little m. So we're going to go to milli. That's an F. It's horrible. I'm writing with my mouse. Sorry. All right, so we move our decimal over 1, 2, 3, 4 times, and we went 4 times to the right. So we find our decimal, we move over 1, 2, 3, 4 times, physically move it, and we're at 57.9. All right, simple enough. We'll do some more practice in class. Okay, scalar and vector. We need to know the difference between the two. So scalar is going to be represented only by a magnitude, which just means a number. Okay, so an example of that would be distance or speed. So when we do scalar and vector, these are measurements, and a measurement is always going to have a number and a unit. Okay, if it's a scalar measurement, it will have a number and a unit, such as distance. The runner ran 15 meters. Speed, the car went 70 miles per hour. You see what I'm saying? Okay, if it's a vector measurement, it's going to be represented by a magnitude, which is a number and a unit, and a direction. Okay, so the difference here is that the vector has direction. Examples of that would be displacement, velocity, and acceleration. We will become familiar with these 3 new vocabulary words very soon. I'm just kind of introducing them right now for you. Okay, and I know you've all seen Despicable Me, so here's Vector, and remember he's Vector because he's committing crimes with both direction and magnitude. Oh yeah. Okay. I think that's it. We'll do some more of this practice in class. I'll see you then.